Hello class, today we are taking a look at solving pictorially in equations where there's a negative coefficient on the x. So of course we know that could mean that we have a coefficient like -2 in front of our x, or of course we know subtracting x is like having a coefficient of -1 on our x. Now when we want to solve pictorially, that of course means by drawing with algebra tiles. So we want to start by drawing the equation as it is. We know our equal sign is going to be our wall, and we're going to go ahead and have two negative x's. So those are long skinny tiles because they're x's, and they are unshaded because they're negative. And we're also going to have 10 total positives here. And just kind of thinking ahead, I know eventually I'm going to need those in 2 rows because I do have 2 x's that'll be part of my solution. So I'm going to go ahead and set those up as 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 positives here for my constants. On the other side, I'm going to need 4 positive constants, so I'll go ahead and do 1, 2, 3, 4 positive constants there. Now, in order to solve, I need a solution that's x equals a number, and of course that's implied to be positive x. There's no negative in front of that. So I'm going to need to cancel out my negative x's as my first thing, and what cancels with 2 negative x's is 2 positive x's. So we'll draw those in on the left side of our wall there. And of course, those are going to form 0 pairs. So positive cancels with negative, positive cancels with negative. Those ones are going to cancel out. However, since those weren't in my original equation, I can't only add them to the left side of the wall. I must also add 2 positives to the right side of the wall as well. And that just keeps things fair, okay? You can't add something to the left side that you're not also adding to the right side. Okay. From this point, I have a pretty easy grade 7 equation to solve. I now need to isolate those x's that I still have. And to do that, I need to get rid of these constants here. So I want to think about what cancels with 4 positive constants. Well, of course, it's going to be 4 negative constants. So I'll go ahead and do 1, 2, 3, 4 negatives. And those will cancel out all my existing positives. Now, of course, I know when I add 4 negative constants to the right side, I must also add 4 negative constants to the left side, and those are going to cancel there. Okay. Last thing to do, I know that 2 x's is the same as 6 positives, remembering that with this cancellation, basically our equation looks something a little bit like this. Of course, we leave all that other stuff that we've drawn, but that's what we really have. So we want to figure out what 1x is worth, and we can see from each line that 1x is the same as 3 positives on the other side. So I can say that 1x is worth positive 3. Now in terms of verifying this, I want to take my original equation, it's left side and right side, and I want to check that they equal the same number. So my original equation was -2 times whatever x is plus 10, and the right side was just 4. So I'm going to do -2 times what I think x is. I think x is positive 3, and then I need to add 10 to that. -2 times positive 3. Negative times positive is negative, and 2 times 3 is 6. -6 plus 10, negative plus positive, we're going to subtract the numbers. 10 take away 6 is 4, and we'll keep the bigger number. 10 was positive, so positive there. Is positive 4 equal to 4? Yes, it is. And so our solution is verified. It is an accurate solution. Okay, let's take a look at question B. Again, we want to start by drawing our wall. We'll draw our equation, what we already have. We have a single negative x. Again, remembering that subtract x is the same as -1x. We're also going to have 5 negative constants. 1, 2, 3, 4, 5. Drawing those in a single row because I know that eventually I'll have a single x to compare them to. On the other side, I've got 1 positive constant. There we go. First thing to do, cancel out my negative x. To do that, I'm going to need a positive x. Oops, this guy should be unshaded at the start. And this guy is shaded. Those cancel with each other. Of course, when I add that positive x to the left side in orange, I must also add it to the right side. Okay. Next thing to do is cancel out my positive 1 constant that's on the same side as my orange x. So to do that, I need a -1 constant. those ones cancel out as well. And of course, I got to add a negative constant to the other side as well. Finishing up, I can see that one positive x on the right side is worth 1, 2, 3, 4, 5, 6 negatives on the other side. So I can say x equals -6 is my solution. When I verify this, again, I want to be careful with my integers. So I need to do -5, subtract whatever x is on the left side. And then the right side in this equation is just +1. So I need to do -5, subtract, I think x is -6. And of course, the other side is just +1. Okay, when we subtract integers, we want to add the opposite. So we're going to keep our first integer, change our subtract to add, change our second integer to its opposite, and then we'll follow our adding rules. Adding with different signs, we're going to subtract the numbers. 6 take away 5 is 1. We'll keep the sign of the bigger number, which is positive in this case. So is +1 the same as +1? Yes, it is. Our solution is verified. The left side does equal the right side. Taking a look at question C. Draw our wall. Okay, we've got 3 negative constants over on the left side. We'll wait to draw those until we draw our x's, kind of figure out what's going on there. When I look, I'm subtracting x, which of course is the same as -1x. So I'll draw one negative x tile there. We also have 2 positive constants, 1, 2. Okay, and on the other side, we'll do our 3 negatives, 1, 2, 3. First thing I need to do, my solution never has a negative x in it, so I need to cancel out that negative x. What cancels with one negative x is one positive x. Those will cancel out. Of course, when I add one positive x to the right side, I also need to add one positive x to the left side. Okay, in terms of my constants there, I need to get rid of those 3 green constants. What cancels out with 3 green negative constants is 3 positive constants. So those will cancel out together. And of course, I need to add 3 positive constants to the other side as well. From this, I can go ahead and see that 1 positive x on the right side is the same as 5 positive constants on the other side. So I know x is equal to +5. Let's verify our solution, left side and right side. Our left side is just -3 in the original equation, and on the right side we have 2 subtract whatever we think x is. In this case, we want to go ahead and do 2 subtract. We think x is +5. Okay. When we subtract integers, we want to add the opposite, so we'll do 2 plus -5. When we add integers with different signs, we'll subtract the numbers. 5 take away 2 is 3. We'll keep the sign of the bigger number. 5 is bigger, and it is negative. So does -3 equal -3? Yes, it does. And our left side does equal the right side. Question D, we want to start with our wall. We've got 3 negative x's to begin with in this equation. Draw those in. Okay. And we've got 2 positive constants on the other side. Planning ahead a little bit, I am going to want to move those. So I'll draw those somewhere where they're easy to move. With my 8 positive constants on the left side, I know eventually I'm going to want those in 3 rows, and they are going to be on the same side as where they are. So let's go ahead and draw those 1, 2, 3, 4, 5, 6, 7, 8 positives, sorted into 3 rows as best I can. So that's my original equation. Now, again, I know I never have negative x's in my solution, so to cancel out these red negative x's on the left side, I'm going to need 3 positive x's there to form my 0 pairs. Bye-bye, bye-bye, bye-bye. And of course, when I add 3 positive x's to the left side, I'll have to add 3 positive x's to the right side as well. There's my 3 positive x's right there. Now I need to isolate those, which means I need to get rid of the 2 blue constants that are on the same side. So what cancels with 2 positive constants is 2 negative constants. And of course, I'll add those 2 negative constants to the other side as well, and they do some canceling there. Okay. Again, remember, at this stage of the game, everything that we've crossed out doesn't exist anymore. So really what we're looking at is this picture here. Of course, in your work, we leave all that still there, but we just want to keep in mind what we're working with. Now we can see that each of our x's is going to have a value of positive 2. And that is going to be our solution. From here we can verify. Again, we want to look at the left side and the right side of our original equation. In the original equation, it was 8 subtract 3 times whatever we think x is. On the other side, it was just 2. We think x is positive 2, so we'll throw that into our equation. 8 subtract 3 times positive 2. And that's 8 subtract 6, which is 2. 2 is equal to 2, so the left side does equal the right side. With our last one here, again, we want to start by drawing our wall. In this case, we have 4 negative x's. 1, 2, 3, 4 negative x's. And we've also got 12 negative constants. I know eventually those 12 are going to have to line up in 4 rows, so that's how I'm going to draw them. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. 12 negative constants on that side. On the other side, I've got 8 positive constants. Doesn't really matter where these are because I'm going to have to move them. So I'm just going to go ahead and do 1, 2, 3, 4, 5, 6, 7, 8. Okay, getting into my solving. I know I never have negative x's in a solution, so all these negative x's on the right side are going to need to be cancelled. Cancel my 4 negative x's, I'm going to have to put 4 positive x's. And of course, what I add on the right side, I'm going to have to add on the left side as well. 1, 2, 3, 4. Okay. Let's cancel out what cancels. So obviously these 0 pairs over here cancel out. Now I need to cancel the constants that are on the same side of the equation as my x's. Remembering that these are all actually gone. The only constants that are on the same side as an x are the green ones. So it cancels with 8 positive constants is 8 negatives. And all those cancel out. And of course, if I add 8 negatives onto the left side, I must also add 8 negatives onto the right side. 1, 2, 3, 4, 5, 6, 7, 8. Looking at each of our equal 4 rows, we can see that 1x on the left side is equal to 5 negatives on the right side, and that's going to be our solution. Let's verify that. Again, we want to be careful with our integers. In the original equation, the left side was just 8. The right side was negative 4 times whatever we think x is, and then subtract 12. So we want to do negative 4 times, we think x is negative 5, and subtract 12. Negative 4 times negative 5 is positive 20. Same signs, product is positive. We want to subtract 12 from that, and 20 take away 12 is 8. Since 8 is equal to 8, the left side does equal the right side, and we are verified. So you can see we're following the same steps every time. Again, it helps to do a little bit of practice here to be able to think ahead for what you want where in your original drawing, such that you can easily show the solution at the end. I hope that helps.